Conservation of energy is one of the most fundamental concepts of physics. So what is it? Follow Hula Bear on his journey to find out more. Hi, I'm Hula Bear. Before we start learning about conservation of energy, we're going to have to learn about a few other concepts first. The first concept we're going to learn about is work. Follow me. Look, here it says that work is the transfer of mechanical energy to an object by force. So that must mean that work is done when a force acts upon an object to cause a displacement of the object. Let's go to our next destination, the kinetic energy fountain, to learn about kinetic energy. It says here that kinetic energy is the energy of motion. Any moving object will possess kinetic energy, which will allow the object to do work on another object. Let's see what the formula for kinetic energy is. The formula for kinetic energy is Ek equals 1/2 mv squared. Ek must mean kinetic energy, m must mean mass, and v must mean velocity. Make sure to remember this for later. We are now at the field of gravity. To learn about gravitational potential energy, look at the moon. It says that gravitational potential energy is energy stored in an object due to its distance above the surface of Earth or another planet. An example I came up with is lifting weights. You are working against the force of gravity when applying force to the weights. Therefore, work gets stored as gravitational potential energy. The equation for gravitational potential energy is as shown. Eg equals mg delta h, where Eg is gravitational potential energy, m is mass, g is the gravitational field constant, and delta h is height. Remember this for later. We are finally at the last destination, the conversation island. Let's see what's inside this treasure box. I found a paper that talks about the law of conservation of energy. Take a look. I also found a shell in the box, which says that when work is done on an object by an outside force, the total mechanical energy of the system will remain constant. An example of a conservative force would be gravity, because the total work done to move an object in the gravitational field is path independent, which is needed for a force to be conservative. Now, do you remember the two equations I told you? Well, they make up this equation for conservative energy, which is Et, which is total energy, equals 1/2 mv squared plus mg delta h. Now, you know a little bit more about conservation of energy and all those other little topics. There is still a lot more left, so keep exploring and good.